4.3, Triangle Congruence by ASA and AAS. Last time we got our first two triangle congruence, well, they were postulates. And this time we're going to get a postulate and a theorem. Remember, I promised you there were 5. We are now up to 4. So in this lesson, we are going to prove that our triangles are congruent using angle-side-angle postulate and the angle-angle-side theorem. So let's look at our first one. Angle-side-angle, which is ASA, is going to say that if you have 2 angles, and guess what? Where is that side? It is the included side are congruent in your 2 triangles to the 2 angles and the included side in your other triangle, then your triangles are going to be congruent. So let's see what that looks like. We have an angle and another angle, and the included side between those 2 angles. Now, just like with side, angle, side, angle, it is very important that the side is between the 2 angles. So let's look at our first problem here. Which triangles are congruent by angle-side-angle postulate? So let's look at what we have. We have one angle, 2 angle, 2 angle, 2 angle, and we have a side and a side and a side. So all 3 of our triangles have 2 congruent angles and 1 congruent side. Which ones are congruent? Well, we know that it is important that the side is included between the angles. So it's triangle 1 and triangle 2 are congruent to each other here. We would have needed that side right there to make them congruent. So we could write triangle, how do you want to name this one? UVS. I went 1, 2, blank. So I would go 1, 2, blank on this one, EON. Or any order that you want on that first one, just make sure the second one matches up. All right, it looks like you already have an example of your own to do. So let's pause the video and get to that. You should have gotten triangle GHO is congruent to triangle CAT, or some iteration of those where everything's in the same order. That's this first one and this third one here. In the middle triangle and triangle number 2 here, our side is not included. We would have needed that side right there between our purple and blue angles. Okay, let's look at another example here. We have a miniature golf course, and the design plan says that the first hole is to have 2 congruent triangular bumpers. We want to prove that they are congruent. So let's figure out what we're looking at here. We have this triangle here and this triangle here. And so first thing I'm going to do is redraw. So we got this triangle and this triangle. We should have a little more space, but that's okay. So A, B, C, and D, E, F. And let's start off by marking what we're given. Segment AB and segment DE. Okay, that's a nice start. And angle A and angle D. Things are looking good. And what else are we told? That angle B and angle E are right angles. So I'm going to put those in. And I want to prove my triangle's congruent. Well, I have an angle and a side and two right angles. So we are told that B and E are right angles. They are not congruent yet. We need to make angle B congruent to angle E. How are we going to do that? Those are not congruent marks. How do we make those angles congruent? Chapter 2. All right angles are congruent. So we can now mark that angle congruent. So now I see that we have angle side angle. All right, so this is a paragraph proof, which I don't like so much, but you can see that we have our given and our given, and all right angles are congruent, and then we have congruent triangles. All right, go ahead, pause the video, and you do the next one. Okay, you should have seen that you were given your two triangles here, and as you look it over, you see that you're probably going to use angle side angle. We have one pair of congruent angles, one pair of congruent sides, and a pair of right angles. So anytime you see right angles, you know that all right angles are congruent. So when I set up my proof, I'm going to set it up angle side angle. And that way I know I've taken care of each one. So my first angle are the given angles, my side are the given sides, and then to get my third angle, it takes two steps. The first step is angle B and angle E are right angles. We are told that right here. That is a given. And then I can make my two angles congruent because chapter 2, put a big star next to it, we know that all right angles are congruent. And then once I have my two angles and the included side, I can write my triangle congruence statement. So I can say triangle ABC is congruent to triangle AED, and I check that around my triangle, and I use the angle side angle postulate. So these proofs are actually kind of fun. I like these. I like triangle proofs. I think they're entertaining. All right, let's move on. This is our fourth triangle congruence theorem / postulate. This one is a theorem. Everybody has been a postulate up to now, which means they are all accepted as fact. Side, 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 side angle, side, and angle, side, angle. And I always remember that this one is a theorem because it's kind of the weird one. It's angle, angle, side. So what do you suppose is going to be involved in this? I bet we have two angles and a side, but look at where the side is this time. It's out here on the end. So let's look at our theorem. It says if we have two angles and a non-included side that are congruent in our two triangles, then, of course, our triangles are congruent. So let's look at this. What do we have? Well, we have this angle here, and this angle here, and this angle up here, and this angle here. So there's our two angles, and we have a congruent side. Look at where the side is this time. It is a non-included side. But be very careful because it has to be next to the appropriate angle. In our first triangle here, it's next to our purple angle. And where is it in our second triangle? Next to the purple angle. Remember, in congruent figures, order matters. They have to be corresponding parts. So make sure that you're using the correct side. Now this again is a proven theorem. And how would we prove this? Well, look at our two triangles here. What do we have? Is there anything that we could do to get to one of our postulates? What about these two angles right there? Do we have any way to make those angles congruent? How about our third angle theorem? And then we could use this angle and our included side and use the angle side angle postulate. And these should all be appropriately labeled. All right, so that is a very simple proof to get to the angle side theorem. Let's look at our example of a proof here. We are given this figure. What's the first thing you notice? First thing I saw, we've got parallel lines. Why do we care about parallel lines? That's right. It means we have special angle pairs. So the first thing I'm going to do is draw my parallel lines and my transversal, because I bet I'm going to use those. All right, so we have our triangles here. I might just redraw my triangles too. It's always kind of useful to have them separate so that you can see them. And then I can erase those. I can keep this clean. Well, what's the first thing we know? We know that we have these angles here. So I'm going to mark those angles. And you should see that. Right? So we have a side. Well, how are we going to prove these triangles congruent? We could either use, well, we don't have an included angle. Another side wouldn't help us, but another angle might. And then we could use our angle side theorem. So which angles are we going to be able to use? Well, let's take a look at our parallel lines here. And let's just kind of dash in our triangles. Now, we know that we have lots of special angle pairs. Which ones are going to help us? I'm thinking it's going to be the alternate interior angles. Well, which alternate interior angles is it going to be? It's going to be this one right here and this one right here. So which angles are those on our triangles? It's this one right here and this one right here. We need to make those two. Those are twos. Why didn't we use the other set of alternate interior angles? Well, look at where they are. They go here and here, correct? Well, look, that goes beyond the triangle. Those are not part of the triangle. Alternate interior angles are going to be very useful to us in triangle congruence and when we're dealing with other figures that have parallel lines. But you have to be extremely careful that you are choosing the appropriate angle. So again, this is where redrawing and labeling comes in handy. So if you draw your parallel lines, draw your transversal, find the angles, right? We've got two sets of alternate interiors there, and then just do a light sketch in of your triangles and see which ones are actually part of the triangle. So let's look at our proof. Here's our angle. We've got our first angle right here. That was given to us. And then we're also given that we have parallel lines. Why did we do that? Because this is going to give us our second angle, right? The alternate interior angle theorem. And then here is our side. Reflexive property of congruence, that's our friend. And that lets us, we have angle, angle, side. That lets us write our congruence statement, and that should be angle, angle, side theorem. We write things properly here. All right, so why don't you go ahead and look at the next one. Pause the video, do the next one. Okay, that was pretty easy. We were given our congruent angles, S and Q there, and then we were told that segment RP bisects, oh, flashing red lights here, bisects angle SRQ. So I know I'm going to have two congruent angles, so I come over to my diagram and find segment RP and find angle SRQ, and I bisect it. Bisect means two congruent angles, so that is just definition of angle bisector, right? Definition of angle bisector. I can mark those two angles congruent, and you should be very familiar with our reflexive property. Our triangles are sharing a side, so reflexive property, I told you long ago, we were going to use that far more than you could ever imagine that we would. So when I do my proof, I look at my triangles, I see angle, angle, side, right? And my side is next to my 2 angle mark on both triangles, so we're good. So I set up my proof, angle, angle, side. My first angle was given. My second angle, now it has to be named with 3 letters. That's definition of angle bisector. Lets me say those angles are congruent. And then my side is the reflexive property of congruence, and then I can just write a congruence statement using the angle, angle, side theorem. And then part B says, how could you prove it by ASA? Well, we would just use our third angles theorem, right, to get our third angle up there, and then we would just have 2 angles and an included side that would let us do it. But that would just be an extra step. We have our theorem that lets us make it a little shorter. All right, and our last problems here. How do we determine if triangles are congruent? All right, let's look at our 2 triangles. What do we have? We've got an angle, and another angle, and another angle, and a side. Are our triangles congruent? I've got 2 angles and a side. Are they in the proper order? Are they angle, side, angle? Nope, not included. That's not the included side. How about no, segment FB and segment OT are not corresponding? That looks like something we might choose. Are they congruent by angle, angle, side? No, that is still not the appropriate side. This side is next to the purple angle here and next to the blue angle here. This one goes blue, purple, and then side. This one goes purple, blue, and then side. Not the right order. No, angle B and angle U are not corresponding angles. They are. They're congruent. That one doesn't make any sense. So our answer is B. All right. Last problem. Go ahead and pause the video. We'll be back to discuss it in a second. Okay, we are asked if the 2 triangles are congruent and explain if they are. And yes, they are, because we have our 2 blue angles that are given. We got our green angles by the vertical angle theorem, and we were given our side there, and our side is in the appropriate position. We go blue, green, side, blue, green, side. It's in the right order, so we can write our congruence statement and say that we used angle, angle, side theorem. So we now have 4 triangle congruence, postulates and theorems, 3 postulates, 1 theorem. that we can use to prove our triangle's congruent. Actively look for those vertical angles and reflexive property. You've seen that that is very useful. Don't forget about right angles. Don't forget about definition of perpendicular is a right angle. We like right angles. I believe that you are going to do very well on these proofs. Make sure you do your define, explore, and set it up so that you are, like if you're going to use angle, angle, side, set up your proof so that you do the angle and then the angle and then the side. And your congruence statement will write itself. I think these are a lot of fun. I hope you enjoy them as well.